Hello and welcome to Nikolay's genetics lessons, and today's problem is in this pedigree how many individuals are in the inbreeding path from A's parents to the common ancestor and back. So basically what we see here, we see that individual I is a great grandmother of A. Probably she were married twice and had two husbands and two male children in each marriage. So individual E and F would be half brothers. They married and had children, so these children would be half cousins, and these half cousins had the child A, and child A would be inbred, and none of the other people here would be inbred, would be related, but none of them would be inbred. And in order to make picture clear for you, I want to redraw this picture, this pedigree, as a line diagram. So we start with individual A, and individual A has two parents, parent B and parent C. And parent B also has two parents, parent E and parent D. And parent C also has two parents. One is parent F, another is parent G. And E and F both related to each other through their mother. So I, individual I, mother of E and F here on the top. So this is going to be our loop here, and it is obvious that individual A is inbred. And of course individual E here also has a father, H, and individual F has a father, J. But these people are unrelated to those people on the other side of the to other branch. So individual H is not related to any of these individuals, and individual J is not related to individual E or B. The same we can say about other parents here. So let's concentrate only on this loop and people who would be direct ancestors of the individual A. And now I'm going to explain two different methods how we calculate inbreeding. Sometimes you see in my videos that I count number of passes, and sometimes you can see that I just count number of nodes. Why I'm doing so, I want to explain you in this video specifically, and along my explanation we will find the answer to today's question. So imagine that individual I, and we all deployed, so individual I may have two alleles, for example A1, and another allele would be A2. What is the probability that individual A would be homozygous by descent for allele A1? And probability would be as follows: 1/2 probability that individual E, son of this female, would inherit this allele. Then once again 1/2 probability that individual B would inherit, and 1/2, 50% probability that individual A would be homozygous for would get this allele through the mother side, and this is father. So let's count: 1/2, 1/2, 1/2. So probability would be 1/2 in a power of 3 that this individual will get A1 allele from the mother side. But this individual also can get the same A1 allele through the father side. And probability would be the same. 1/2 here, 1/2 here, 1/2 here. So probability for this individual to be homozygous by descent for two same alleles inherited from the same common ancestor of his parents would be 1/2 in the power of 3, 1/2 in the power of 3, and we have to multiply these two probabilities. So probability for this individual to be homozygous for A1 allele would be 1/2 in the power of 6. But this is not going to be inbreeding coefficient because individual A also can be homozygous by descent for the A2 allele. So we also have include this probability in our calculations. So let's do it. So probability that individual A would be homozygous for A2 allele would equal to 1/2 here, 1/2 here, and 1/2 here. So the same 1/2 in the power of 3, and probability that this individual A would inherit A2 allele from the common ancestor of his parents also would be through his father side would be 1/2 here, 1/2 here, and 1/2 here. So would be 1/2 in the power of 3. So joint probability that these two alleles would happen in individual A would be 1/2 in the power of 3 multiplied by 1/2 in the power of 3. So we are going to get 1/2 in the power of 6. And now we have to add these two probabilities because we are looking for the probability for this individual to be homozygous for the same allele inherited from common ancestor of his parents. So we have now to add these two probabilities. So we have add 1/2 in the power of 6 plus 1/2 in the power of 6. In other words, this is going to be 1/64 plus 1/64. And the answer would be 1/32. And now, second method, how we can calculate inbreeding coefficient. So this number is inbreeding coefficient of the individual A, or probability for him to be homozygous for whether A1 or A2 allele, homozygous by descent. We just have to calculate number of nodes excluding individual A, our proband for whom we do our calculations, but including his parents. So starting with one parent through the common ancestor and ending with other parent. So let's do it. And this is going to be first node, second node, third, fourth, and fifth. And now let's check if our answer would be the same if we would use this second method, just calculating number of nodes. And in this case, our calculations would be as follows. So we got 1/2 here in the power of 5 nodes. And this is going to be 1/32. The same answer as you see as we got before, but this time our calculations is much more easier. We don't have to do it twice, and we don't have to count number of the passes, which would be 6, but number of nodes would be 5. And let's now pay attention what is said in our problem. And in our problem we are told to find the inbreeding path from A's parents, so from A's parents to their common ancestor and back. And as you see, if we wouldn't include these parents from A parents, then we are going to get 3 nodes, or 1, 2, 3, 4 passes. Neither 3 nodes would help us to calculate inbreeding coefficient of the individual A, nor 4 passes would help us to do it. Only whether 6 passes would help us to do it if we would do it twice, or 5 nodes. And as you see, this is going to be our answer A. Number of individuals or number of nodes starting from parents, including parents, would be 5. So I hope that now you understand why sometimes I'm using method of calculating number of passes, and why sometimes I'm using just finding number of nodes, because second method would be faster. But sometimes, in order for students to understand the logic, it is easier to use the pass method, because the second method is shows the logic, and the first method, counting nodes, is just faster, but sometimes students do not understand the logic behind this. And logic is simple. If we calculate number of nodes, we are going to get 1/2 in the power of 5, and this is going to be the same as 1/2 in the power of 6 plus 1/2 in the power of 6. I wish you good luck on your exams, and this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. Thumbs up if you like this video. Please write your comments, questions if you have any. Share this video with your classmates, and see you in the next video. Goodbye.